This is problem number 24 in chapter 3. It reads, an athlete executing a long jump leaves the ground at 28-degree angle and travels 7.80 meters. Part A asks, what was the takeoff speed? And Part B asks, if this speed were increased by just 5%, how much longer would the jump be? I'm going to make a quick sketch over here on the right-hand side, and we should recognize a couple of things. First of all, in the long jump, the jumper basically takes off at some point, which I've indicated here by the green dot, and lands at some other point. And so we have an initial Y position and a final Y position that are both on the same plane. So therefore, I can say that my vertical displacement in this case is equal to 0. I've got everything that I need, all that I need to know in order to use the range equation. So you should be thinking to yourself, when these conditions are met, so y is equal to 0, you can use the range equation. Let's go ahead and write the range equation out. The range equation, which we've derived and you'll be given on summative evaluations, is v naught squared times the sine of 2 theta all over g. So we have v naught. Let's go ahead and write down what we know. We have, actually we're looking for v naught. That's what's being asked for. Of course we have g. It's going to be equal to 9.8 meters per second squared. Also recognize that g, the negative sign, has already been accounted for. Anytime that you're substituting g, you don't apply the negative 9.8. The negative sign. If you're plugging in gravitational acceleration in for the more generic a, then the direction has not been accounted for and you do need to put the negative sign in. Okay, so let's see what else we have in this problem. We have the range. The range is equal to 7.80 meters, and we also know the angle theta is equal to 28 degrees. Okay, so if I rearrange this equation, I'm going to multiply both sides by g. I get rg, and I'm going to divide both sides by the sine of 2 theta, and yikes, there we go. And I'm going to take the square root of both sides, and that's going to basically give me an expression for my initial velocity, and that's what I'm looking for. How fast, I know that this angle theta was 28 degrees, but how fast was I going when I took off? So this expression that I've written here describes that in terms of the range equation. Going ahead and plugging some things in for those values. My range is 7.80 meters. I'm going to be multiplying that by the acceleration due to gravity, 9.8 meters per second squared. And I'm going to be dividing the whole thing by the sine of 2 times 28 degrees. When I plug that into my calculator, I'm just going to type it in as sine 56. And all of that's going to be equal to my initial velocity. When I run that through my calculator, I get 9.60, that's a 6, meters per second being my initial velocity. So that's my answer for part A. Oops. Let me undo that. There we go. Okay, so there's my answer for part A. Moving on to part B. Part B asks further, if the speed were increased by just 5%, how much longer would the jump be? So in this next part, what I'm going to do is take my initial speed that I've just figured out. So I'm going to take this 9.60 meters per second, and in order to multiply it by, or increase its value by 5%, I'm going to multiply it by 1.05, and that's going to give me a value of 10.1 meters per second. 10.1 meters per second. And so now ultimately what I'm answering is what's going to be my range given the same launch angle if I'm jumping a little bit faster, 5% faster at 10.1 meters per second. Let's go ahead and recognize again that this is a level horizontal projectile, so I can use the range equation. Range is going to be equal to v naught squared sine 2 theta all over g. And so therefore I'll plug in my initial velocity, which is now not 9.6, it's 5% faster, so it's going to be 10.1 meters per second. I need to make sure that I remember to square that. The sine of 2 times 28 degrees, again, that's going to be 56, and all over 9.8 meters per second per second. When I plug that into my calculator, I'm going to get about 0.8 meters beyond my range that I calculated in the first problem. So in the first problem, I had a range of 7.8, and in the next problem, I'm going to have a range of 8.6. So now I can say that my range for part 2 is going to be 8.60 meters. Therefore, I can say that my range has increased my horizontal displacement or my range by about 0.80 meters. Oops, 0.80 meters. And I can ultimately answer the question by saying that my range has increased by about 10%. And so therefore, the kind of final answer to part B would be kind of all of this information here in the red box.